Welcome. In this technical track, we will be discussing how the PISTIS database platform handles the value transactions for data payments in trading. First of all, let me introduce you to PISTIS project. PISTIS is a European-funded initiative that reshapes how organizations share and trade data. Rather than forcing everyone into a single centralized platform, PISTIS creates a federated ecosystem where data owners maintain control while participating in a trusted marketplace. The project aims to develop a reference platform for the sharing, trading, and monetization of proprietary data. PISTIS uses many technologies to handle data management, analytics, sharing, and monetization, aiming to deliver a secure, trusted European data space. The PISTIS platform is a federated environment of collaborating stakeholders governed by a central cloud-based entity. Stakeholders are operating a PISTIS data factory deployed on their premises. The data space factory environment is responsible for data publishing, data transformation, enrichment, and execution of data trading operations. Each participating organization operates their own data factory, ensuring data never needs to leave their secure environment unless explicitly authorized. The PISTIS Cloud platform governs and orchestrates operations related to data monetization and data market exchanges. Throughout this course, we will concentrate on how the PISTIS data monetization bundle enables seamless, secure payments for data trading. This component bridges traditional finance with distributed ledger technology, allowing users to convert euros to PISTIS tokens, execute transparent, traceable value transactions, manage both fiat currencies and digital assets in one unified wallet, participate in incentivized data trading with automatic compensation. By the end of this course, you will understand not just the technical architecture, but the economic and operational advantages of combining DLT with traditional financial systems for data marketplaces. Data has value, but realizing that value requires infrastructure that can handle pricing, transactions, rights management, and payment settlement. The PISTIS data monetization bundle provides exactly this infrastructure, transforming data from a static asset into a tradable commodity. It is mainly concerned with helping users to publish their data, understand their value within the marketplace, and participate in incentive trading. The data monetization bundle leverages distributed ledger technology designed specifically for payments and digital asset trading. Unlike energy-intensive blockchain protocols that require massive computational power, PISTIS uses an efficient, scalable solution suitable even for resource-constrained environments. Users operate within a dual currency system: euros from traditional money maintained in banking systems, PISTIS tokens from DLT-based tokens used for data marketplace transactions. The bundle manages conversions between these currencies seamlessly. When you want to buy data, you deposit euros into your PISTIS wallet. The system converts euros to PISTIS tokens at current exchange rates. You use tokens to purchase data in the marketplace, and then the sellers can convert received tokens back to euros when desired. This hybrid approach combines the familiarity and regulatory compliance of traditional currency with the transparency and efficiency of DLT-based assets. At the heart of the PISTIS data monetization platform lies a revolutionary technology, which is called distributed ledger technology, or DLT. To understand why PISTIS uses DLT and how it enables trusted data trading, we need to explore what DLT is and how it works. DLTs are decentralized computer systems in which multiple independent nodes communicate with each other to simultaneously validate and update a record of transactions. Working under specific protocols, it allows users to access the same ledger. It is essentially a database that exists across multiple locations or among multiple participants. Rather than a single centralized server controlling all data, DLTs create synchronized copies of information across many independent nodes. As data becomes increasingly valuable, the need for trusted, transparent, and immutable medium of exchange will only grow. DLTs provide the foundation for data marketplaces that are more efficient than traditional broker-based systems, more transparent than opaque private transactions, more secure than centralized databases, and more scalable than manual contracting processes. PISTIS doesn't just use any distributed ledger technology. It specifically leverages IOTA, an innovative and efficient DLT protocol. To understand why PISTIS chose IOTA, we need to explore its unique architecture and advantages. In the context of PISTIS, the IOTA streamer testnet has been adopted as a scalable, fee-less solution. At the core of IOTA lies a revolutionary data structure called the tangle, a directed acyclic graph serving as the ledger's underlying data storage structure. Unlike traditional blockchains that organize transactions into linear sequences of blocks, the tangle is a structure where multiple transactions can be processed simultaneously, storing them as vertices in the graph. Whenever you submit a new transaction to the IOTA network, three major activities take place. Selecting parents, which means the transaction selects and references a small set of recently included predecessors as its parents in the graph. Perform proof of work, when a lightweight cryptographic puzzle to regulate network traffic and mitigate spam is amputated. The proof of work is so easy to compute so that even the user himself can do it. And third, the validation. By submitting a transaction, the reference parent transactions are approved. This creates a symmetry. Every participant who wants to transact must also contribute to approving other transactions. The participating nodes do not receive any tokens as rewards. All we send is all we receive in IOTA. This makes the IOTA a low-cost, energy-efficient, fee-less, and scalable solution. A key feature of the IOTA consensus algorithm is a special component called the coordinator. It is a node that periodically emits special blocks called milestones. Milestones can be thought like checkpoints in the network. Any transaction referenced directly or indirectly by a milestone block are automatically considered valid and confirmed by all participants. Milestones validate transactions and cannot alter the ledger state, performing digital asset transfers. Milestones are regularly issued and achieve transaction finality times within the range of 10 to 15 seconds. While the coordinator seems like a centralized application of consensus mechanism, in reality it can be formed by a validation committee of multiple different nodes. At the end of the day, the coordinator guarantees transaction finality within predictable time and a smooth path towards decentralization. IOTA supports non-fungible tokens, which PISTIS uses to represent data assets. Non-fungible tokens are unique digital assets that have been tokenized via a DLT protocol and cannot be copied, substituted, or subdivided. They may represent ownership and authenticity of digital or physical items within the active applicable legislative framework. Let's recap on the key advantages of IOTA. Perhaps IOTA's most revolutionary feature is that there are no transaction fees. In traditional blockchains, miners charge fees to prioritize your transactions. In IOTA, consensus is achieved not through monetary fees, but through computational effort. Each new transaction validates earlier ones, helping secure and advance the network. This makes IOTA perfect for data marketplaces, where microtransactions for small datasets are economically viable. Frequent trading does not accumulate prohibitive costs, and all value transfer goes to the data provider and the platform, not intermediaries. Because multiple transactions can be processed in parallel rather than sequentially, the tangle's performance actually increases as more participants join the network. More users mean more simultaneous validation, creating a positive feedback loop. This fundamental difference makes IOTA inherently more scalable. Transactions achieve confirmation within 10 to 15 seconds. IOTA is a low-cost, energy-efficient, fast, high-performance, scalable, and fee-less DLT suitable for deployment even in low-end devices. These characteristics make it the ideal foundation for the PISTIS data monetization ecosystem, enabling trusted, transparent, and economically viable data trading at scale. IOTA's lightweight proof-of-work mechanism is well suited for low power requirements of IoT hardware, eliminating the cost barrier for devices with limited computational resources. PISTIS can run IOTA nodes even on modest server infrastructure without requiring data centers full of specialized mining requirements. Last but not least, it supports NFTs and smart contracts. Now that we have explained the technologies underlying PISTIS, let's explore how they come together in a practical architecture that users interact with. This module, the PISTIS wallet, examines the three primary components that enable seamless data monetization. The PISTIS monetization exchange platform consists of three interconnected components. The PISTIS monetary ledger, which is the foundation layer maintaining the distributed ledger. The digital DLT-FIAT wallet, which is the bridge connecting ledger, banking, and platform. And the NFT generator, which is the component creating unique tokens for data assets. Think of these as three layers of a sophisticated payment infrastructure. The ledger as the accounting system, the wallet as the user interface and integration layer, and the NFT generator as the asset tokenization engine. The PISTIS monetary ledger is essentially a collection of deployed IOTA nodes, collectively maintaining a ledger that supports value transactions. It is currently a permissioned private network not publicly accessible. Each participating organization deploys one node on their premises, maintaining local copies of relevant value ledger data. A special node, called permanode, is deployed in the PISTIS cloud that stores the complete transaction history since the ledger's genesis block. User nodes only need to store recent activity, saving storage space and computational resources. The permanode ensures no historical data is ever lost and provides a reference point for synchronization. The permanode also runs the coordinator module, issuing milestone blocks that provide fast finality and network security. Several auxiliary services enhance the monetary ledger functionality. The faucet that manages the circulation and distribution of PISTIS tokens, similar to how central banks manage currency supply. Indexer that provides efficient setting and traversal of the ledger, enabling quick queries like show all transactions for this user. The MQTT service that sends real-time notifications to users about events like incoming payments or transaction confirmations. The node dashboard that offers monitoring and health status for all nodes in the network. The smart contract modules, which are additional software components enabling layer 2 contract execution. And security infrastructure, which is firewalls and traffic monitoring mechanism protecting the network. This is the most sophisticated component existing in all user premises and the cloud. It is the bridge between three essential pillars: other PISTIS platform bundles, the PISTIS monetary ledger, and the traditional fiat banking system. We will explore the wallet in much greater detail in the next slides, but its role in the overall architecture is to provide a unified interface where users can manage both euros and PISTIS tokens, convert between fiat and digital currencies, execute data purchase transactions, view transaction history across both domains, and receive notifications about payments and settlements. The NFT generator is responsible for creating unique tokens representing data assets in the marketplace. Each dataset in the marketplace can be tokenized as a unique NFT containing metadata describing the dataset's characteristics, embedded license terms, and lastly, ownership records showing current and historical holders. The platform employs a dedicated digital wallet to mint IOTA-based NFTs. To maintain data integrity, only the platform itself can issue NFTs, ensuring that each dataset is represented by a single unique token. This prevents duplication and ensures reliable tracking of ownership and provenance. In order to further explain how the components work together, we will give a typical transaction flow. A seller uploads a dataset through the platform. The NFT generator may create a unique token and list it in the marketplace. A buyer browses the marketplace, finds a valuable dataset, and decides to purchase it. The buyer's DLT-FIAT wallet checks their token balance. If insufficient, it facilitates conversion from euros to PISTIS tokens. The wallet interacts with the monetary ledger to transfer tokens from buyers to seller and update NFT ownership. Both parties receive MQTT notifications confirming the transaction. The buyer can now access the purchase dataset. The seller's wallet now shows increased token balance. They can convert back to euros whenever desired. All of this happens automatically, typically within seconds, with complete transparency and auditability. The digital DLT-FIAT wallet is the component users interact with most frequently. It's the face of the PISTIS monetization platform. But beneath its user-friendly interface lies a sophisticated three-layer architecture that seamlessly bridges traditional banking with blockchain technology. Most cryptocurrency wallets manage only digital assets. Most banking apps handle only fiat currency, but the PISTIS DLT-FIAT wallet does both, creating a hybrid unified experience where users can hold euros in linked bank accounts, manage PISTIS tokens in blockchain wallets, convert instantly between currencies, execute data purchases, and view consolidated transaction history. This hybrid approach addresses one of the fundamental barriers to blockchain adoption in enterprise contexts: the friction of moving between traditional finance and crypto ecosystems. The PISTIS DLT-FIAT wallet can be conceptually divided into three layers: the main intermediate layer, the fiat-aware layer, and the DLT-aware layer. The main intermediate layer is the entry point to the component, the interface through which all other PISTIS bundles and components communicate. Its responsibilities are as follows: authorization, authentication, logging, and access control, coordinating complex workflows like fiat to token exchange, tracking balances, transaction history, and user preferences, propagating incoming transaction alerts to users, providing standardized interfaces for other platform components. You can think of it as the command center that receives requests, determines what actions are needed, coordinates between the other layers, and returns results. Concerning the fiat-aware layer, this layer handles all specific communication between the platform and financial institutions. The wallet can create and manage fiat accounts in connected banking systems. For PISTIS demonstrations, this includes integration with a simulated banking system that mimics real banking operations. The platform currently supports ISO 20022, the global messaging standard for financial transactions that provides richer, more structured data than legacy formats. The system is designed to allow the integration with other protocols in the future, such as the PSD2 Open Banking Regulation, which mandates European banks provide third-party access to customer accounts through secure APIs. Within the PISTIS concept, the main functionalities of the fiat-aware layer include the following: creation of fiat currency accounts for new users, processing deposits from external bank accounts, executing withdrawals to users' primary banks, managing currency conversions, and finally, maintaining records of financial reporting and compliance. The DLT-aware layer is responsible for connecting the PISTIS platform with the PISTIS monetary ledger, acting as a bridge between PISTIS platform and DLT nodes. The wallets are non-custodial, meaning private keys are managed on the end user's premises, not by the PISTIS platform. The platform does not keep copies of users' private keys, nor the ability to perform any actions without their explicit authorization. This approach gives users complete sovereignty over their digital assets, eliminates the platform as a single point of failure, aligns with the decentralization philosophy of DLT technology, and ensures regulatory compliance in jurisdictions requiring user control. While PISTIS currently supports IOTA protocol, the architecture follows design principles, enabling future support for multiple DLTs. This layer abstracts DLT-specific operations behind standard interfaces, so adding new ledger support doesn't require rebuilding the entire system. In conclusion, the PISTIS DLT-FIAT wallet represents the successful convergence of traditional finance and distributed ledger technology. By thoughtfully architecting three distinct layers, each optimized for its specific domain, the platform delivers an experience that's simultaneously familiar to banking customers and native to DLT ecosystems. users gain the benefits of DLT, meaning transparency, efficiency, and automation, without sacrificing the convenience and compliance of traditional finance. Why this architecture matters? The PISTIS architecture demonstrates how to build practical, enterprise-ready systems using distributed ledger technology without sacrificing usability, performance, or regulatory compliance. By carefully separating concerns such as ledger foundation, asset tokenization, and user-facing financial operations, the platform achieves both sophistication and simplicity. Users don't need to understand the complexity underneath. They simply deposit euros, browse data assets, and make purchases, while the architecture handles all the complex coordination between traditional finance and DLT technology. Thank you very much.